All right, before the break, we talked about oxygen and the hemoglobin saturation curve, and I tried to emphasize that the partial pressure of oxygen, that's the number one influence that gives us that S-shaped curve. There are other things in physiology that can, well, they don't determine the sigmoid shape, but they can kind of shift that curve to the left or to the right. And so I want you to note temperature, blood pH, the partial pressure of CO2, and something called BPG. Write that down. And let's think, for example, during the condition of exercise. Temperature. Rest versus exercise. Body temperature increases. Let's think of the pH of the blood. Got the lactic acid buildup, burn of exercise. pH tends to drop during exercise. The partial pressure of CO2 increases. The last thing is BPG. BPG is a molecule. Another slide on it. It tends to bump oxygen off of the hemoglobin, and it increases during exercise. Well, anyways, during exercise, all of these things occur, and they all facilitate oxygen unloading, more oxygen unloading. Put it another way. Hemoglobin bound to oxygen, that chemical equation can go either way. Is our hemoglobin plus O2, just to put that in chemistry form. You're just getting more of this. Oxygen is free to enter the tissues. Okay, so this is basically during unloading. And actually, these determinants, let's go through the next slides. I'll show where I'm going with this. What we had talked about before the break is that the plateau depending on where you are, up in the mountains, or sea level, obviously, he's on the beach. Wherever you are, if the oxygen tension drops off, even if you drive up to the mountain, the saturation doesn't change very much. You're pretty well saturated even at altitude in thin air. Okay, so I said that the plateau is good for external respiration, breathing that air. But now think about the tissues. In a condition of rest, just reclining at the park, here's the metabolic needs. The PO2 is 40, so the saturation was about 75. But with your working out, man swimming, okay, and basically, well, PO2 drops to 20. We said that the saturation was much less, maybe about 40%. Okay, so what I taught was that the steep slope was good for dropping off O2, good for internal respiration. So the thing I didn't mention about exercise is about the BPG. That's actually an acronym for 2,3-5-phosphoglycerate. So talking about red blood cells, because they're the ones that bind oxygen, they're specialized for, non-oxidative metabolism, because let's remember, they kicked out their nucleus and everything else. So they have to have metabolism that's non-oxidative. That way, they don't burn the O2 they transport. Okay, think about it, that's a good thing. Now, one of these enzymes for their non-oxidative metabolism is BPG, and that's something we can measure. And what we've noticed is BPG, it binds the hemoglobin at a site that negatively affects the binding of O2 to hemoglobin. So what I'm saying is BPG bumps off the O2. So BPG levels are elevated during exercise, along with all these other things. They all facilitate oxygen unloading, which is favorable for the condition of exercise. So something I want you to think about is normal versus shifted, one way or to the other. Well, let's look at this shift first. So down and to the right. Instead of a dotted line, I use a different color. Shift it down and to the right. Now, before I proceed, there's a normal value that acts as a baseline for our black normal oxygen hemoglobin saturation curve, and that baseline is P50, referring to that. P50, to define it, is the oxygen tension, or the PO2. Well, that provides 50% saturation. The oxygen tension, well, we've been calling that PO2. That provides 50% saturation. So let's just kind of add it. Here's 50% saturation on our graph. And so it's about the value is 27. Under normal conditions, P50 is 27 millimeters of mercury, PO2. Under normal conditions of rest, like you are now, P50 is a PO2 of 27. So what I'm saying now is, now we're going to have a shift. All of these things facilitate oxygen unloading during the condition of exercise. So I'll kind of put kind of a red thing here, just kind of, so associate these factors with this shift down and to the right. And how you interpret that shift is you're dropping off more oxygen at any given PO2. For example, when you shift this way, how does P50 change? All these things. Write that as a question for you. Increase or decrease? Increase or decrease? Class? What do you think? Look at the graph. Is P50 increase or decrease? It increases. Now it's like 50%. I gotta go right? Whatever that value is, well, you can see it increases from 27. Okay. So, okay, check it. Boom, increase. What does that mean? It means, well, it takes more oxygen to saturate at 50%, right? Let's put a number to it. I don't know. Let's say it's about 34, some arbitrary higher number. Well, now to saturate under these conditions, you have to get more oxygen to saturate at 50%. Okay, that's what that means. So I guess that's a good thing, because during exercise, you want the conditions to be favorable to drop it off. All right, and now all this that I'm explaining, of course, there's a term for it. This is called the Bohr effect, where you shift down and to the right. Let me put my notes here and phrase it the right way. Okay, so all of these things will cause a rightward downward shift of this curve. Cause a rightward downward shift of the oxygen, hemoglobin, saturation, short sat, curve. And we just call that the Bohr effect. I talked about one shift. I guess you can shift it the other way too. You can shift it up and to the left. Okay, you can shift it up and to the left. Well, if these things cause a rightward shift, I guess you can just reverse everything, and that will be your other shift. I'm going to erase the P50 thing here. That's important. That's our reference point. P50 under normal conditions is 27. Now, let's think at the lungs. For example, your core body temperature is 98.6 degrees, but isn't the air you breathe much cooler? Even on a hot day, like 80 degrees outside, it is still cooler, especially on a cold day. The air you breathe is cooler than your core body temperature usually. Therefore, the temperature in the lungs drops. Just to give an example. And also, like for example, there's less CO2 in the lungs, so the pH tends to drop, and so the pH tends to raise, and the PCO2 tends to drop. It's just the reverse. A little bit up, PCO2, a little bit down. You're ventilating to keep CO2 low in the lungs, and also, let's just say BPG drops. And all of those things cause this leftward, upward shift. Now, P50 has decreased, right? Again, these aren't textbook numbers. The only number that's textbook is 27. I just put an arbitrarily higher number and lower number to show you that P50 does increase or decrease. I'm not strictly drawing my red line or blue line in any particular way. Okay, but the number to know under normal conditions, multiple choice, 27. Okay, that's the textbook value. So it's kind of like, well, what does this all mean? It's like, imagine hemoglobin and you're like an oxygen molecule and you're sitting in a chair just like you are now. Under normal conditions, the chair is like just a regular chair. It's like horizontal. And you sit in the chair. Now you can get out of the chair. You got to stand up. That does require some effort. Okay. It's like if you shift it to the right and oxygen you're facilitating the unloading with the Bohr effect. It's like if you kind of slant the chair a little bit. Now, you can still sit in that, but it's easier to slide off, right? So that's why it takes more oxygen to saturate at 50%. It's harder to sit there. More oxygen is sliding off, so it takes more to like fill it to 50% capacity. Now, so then in my chair analogy, it's like if you have a chair that's kind of slanted up, once you get in that chair, it's more difficult to get out than any other condition. So that's why it takes less oxygen to saturate at 50%, because it's harder for oxygen to get off, so there's more that stays on. Okay, so that's why you see these shifts, the ability of hemoglobin and its affinity for the oxygen there. So that's kind of my next slide. And your book gives you this information. I kind of put my notes right here on the bottom there. I just put all the ones for the Bohr effect, right? I like that. I always like to use exercise in this part of the lecture because all these things happen together, okay? Like they have one for body temp, they have one for CO2, right? And they kind of show you what happens. Okay, so that refers to core body temperature. So obviously this is the one for exercise, and the other ones are shifting it the other way. So to summarize, the shifting of this curve down to the right during exercise, right? That's the Bohr effect. It facilitates oxygen unloading from oxygen from hemoglobin of blood passing through active muscle beds. That's how you want to think of it. You're working out, you're huffing and puffing, your cardiac output maybe increases by 5-fold. And you're dropping off more O2 because of the whole curve is just shifting. So it's easier for oxygen to be delivered. This unloading makes it available to tissues to support their metabolic demands. So now that's the Bohr effect. That actually affects the next thing I want to talk about, the transport of carbon dioxide. Before I move on from the Bohr effect, are there any questions on the Bohr effect? Or the shifting either way, to the right, to the left? We'll talk about the transport of carbon dioxide. You can erase this. So this next test is on proctorial. Keep that in mind as I go through the material here. Let's see. Now, we talked about the transport of CO2 3 ways. I had to take notes on this earlier. I won't rewrite it. I gave you numbers. 60 ml of CO2 per deciliter of blood. We put numbers to it. Well, in terms of percentages, 7, 23, 70. Okay, if you look at your notes, it was like 40 ml, 15 ml, and I can't remember. I think it was, look at your notes, it's there. But the percentages, most of CO2 is transported in the form of that bicarbonate. So how you want to think of this is the respiratory system is extracting CO2 from the tissues. So the act of ventilation, the partial pressure of CO2, think of it as metabolic waste, is kept low in the alveoli. And the number I presented to you this morning was about a tension of 40 millimeters of mercury. Now, keeping that number low, that creates a gradient for CO2 to move from tissue into the blood, into the alveoli, which you breathe it off to the atmosphere. Here's a picture of that. CO2, 45. You keep breathing, keep the PCO2 low, about 40, and that's your gradient. That allows the CO2 to go from tissue to the blood, to the lungs, and you breathe it off. Okay, and you're just kind of pulling it out of the tissues by breathing. Now, in terms of the chemistry, metabolic CO2, it can form carbonic acid, which then dissociates protons. So that's this equation that I wrote earlier. Let's rewrite it. Good old CO2. One of the things you can do is say you hydrate it with water. That's carbonic acid. It dissociates into bicarbonate plus a proton or a hydrogen ion. Hydrogen has a nucleus of one proton circulating on one electron. So if you remove the electron, it's a hydrogen ion or a proton. That's all that's left right here. This is bicarbonate. And this is carbonic acid, a weak acid that partially dissociates. Well, anyways, that's the chemistry equation that we're talking about. Metabolic CO2 can combine with water. Now, this chemical reaction is very slow, because these are very inert molecules. However, there's an enzyme that can speed it up. Put it over here. That's carbonic anhydrase. That's the enzyme that will speed up the reaction. You actually have that enzyme on the surface of the RBC. And that's why it's important in our physiology here. So this enzyme, think of it as wetting the CO2, right? You're just combining CO2 and H2O. It's not in the plasma, but it's on the RBC, okay? And so here's kind of a picture of what I'm talking about. Muscle cell, and it's like you got CO2 building up. You want to push it into the blood so the blood can take it away to your lungs so you can breathe it off. There's 3 ways it gets in there, right? Dissolved in plasma, that's 7%. Bound to hemoglobin. Remember before the break, we wrote this, and we called it carbaminohemoglobin. Oh, forgot an O. Carbamino. That's our 23%. But our 70% is bicarb. Or just to complete the list, 7%, just good old CO2 dissolved. Right, so I mean, I talked about those numbers before, but this time I just kind of want you to see in picture form. This, check it, 70%, that's the primary way we transport CO2 in the blood. And if you look at the bottom here, there's 2 ways you can do it. In the plasma, because there's no carbonic anhydrase, I put slow because it doesn't happen very much. But on the surface of the red blood cell, I put Ca for carbonic anhydrase. It happens much faster, so obviously that's the way to go. Okay, it's going to happen more on the surface of the RBC. So let's kind of bring it all together. We transport the CO2 in the blood. Let's talk about gas exchange at the peripheral tissues, internal respiration. And let's look at this picture, and I think you should understand everything that's on it. And there's a lot on here. So let's analyze it. Cells, right, of your body. Looks like you have a blood capillary. They show you a red blood cell. They show you the red blood cell, HbO2, right? And there's the O2. And they got a big arrow going off there. And I put Bohr, because let's pretend you're exercising. Does Bohr mean you're going to drop off more O2 or less O2? More O2, dropping off more. Okay, now that actually affects things up here. So let's kind of analyze what's going on up here, and I'll mention good old Haldane in a second there. So here's one thing, CO2 dissolve. What percent is that one? 7, very good. They say slow, they say fast. You know, like I said, you got the carbonic anhydrase. Something that happens here, so you get your HCO3 negative sign on the surface, you want to shift it to the plasma. So what you got to do, you got to make a switcheroo. You got to trade negative for negative. So that's why they call it the chloride ion shift. Okay. For this one. Switch places. That actually gets the bicarb to the plasma. Plasma. Remember plasma? What color was it when we looked at the spun down blood? Kind of yellowish straw color? Yeah. Plasma. Yellow blood. We got yellow blood. What color is your urine? Kind of the same color. What is your urine? It's filtered plasma. Yeah, but hey, it's your blood filtered. Another way to think about blood. Another way to think about urine. Okay, well anyways. Urine is sterile unless you have a bladder infection. Chloride shift. Okay, now you're going to transport it. Now the reason why I put Bohr number 1, Haldane number 2 is to insinuate, you know, that happens in this order. So it's like one way you can transport CO2 is attached to hemoglobin, but that is dependent upon how much you drop off. Okay, let me do it this way. Blood vessel. Cells accumulate CO2. So my blue balls are the CO2. And they're accumulating. And they need to ride out of here. Excuse me. In the flowing blood, you got to get it to the lung. So you're stuck here in the tissues, they're accumulating. You can get into the plasma, but let's just refer to the to the hemoglobin, just that. Okay, and the blue balls. So hemoglobin's coming along with RBC, just like in the picture. And so like it's like, so I've been drawing it as this four square grid. And let's say the bus is completely full. They're all saturated. Because it really is close to saturation, almost like 97, 98%. It's close to saturation. So the only way you're loading CO2 is if O2 gets off. Okay? Like, you know, when I used to take the bus in grad school, I used to stand there, and I always remember, you know, I lived in West LA, and the blue bus would come, and on some mornings I would look, and the bus would be completely full. It's like, oh no. Because if no one gets off the bus, I can't get on the bus, right? The only way I'm getting on is the bus stops. People get off, and I can get on. So that's like me standing at the bus stop, you know, waiting to get on the bus. And so that's what we're talking about here. Remember the PO2 in the condition of rest when you're reclining at the park? What was it? it was like 40. And we had talked about the saturation at PO 240. It was like 75%, right? We're going to talk about this. If hemoglobin at the condition of rest is 75% saturated, how many got off of these four? Just one. So one got off the bus. So how many CO2s can load? One. And we've all taken the bus, right? We know that's true. Usually the bus is empty, but if the bus is full, you're only getting on if somebody gets off. Okay? So I've always wondered why, this is like 23%, almost a quarter. Why is it only 23%? Why isn't it more? Well, it depends how much gets off. About 25% you can load, right? So that's why this accounts for the rest of the transport. Well, anyways, let's say it's the Bohr effect and more get off. More get off. This is the Bohr effect. Lower oxygen tension. More get off. More get off. More oxygen gets off. Then more CO2 can get on. So that's the basic idea. If you drop off more O2, more CO2 gets in the blood. That's it. And I think that's pretty easy to understand. Any questions on that? All right, so let's kind of put that picture into words then, if there are no questions. I'm going to erase some of this. I need to read and write. I'll erase this too. I don't think I need it. Let's remember our Bohr effect, our four things that I talked about just after the break. Partial pressure CO2, pH, body temperature, EPG. What I was saying, during exercise is that all of these values compared to, say, the condition of rest change in a way that, well, PCO2 increases, drops the pH. Okay, now you see why. If you push this equation over here, you contribute more hydrogen ions. That drops the pH, right? CO2 affects the pH. Body temp increases, BPG increases, so all of these changes are basically the Bohr effect. Facilitate more O2 unloading. What did we say about P50? Does that go up or down? We said it increased. Okay, go back and look at your notes. It is there. Okay, wait. This is called Bohr effect. Notice that's a person, right? Bohr effect. And basically, so this O2 unloading allows two things. One, like I said, more get off the bus, more can get on the bus. More CO2 loading to HB. Right, that's the formation of carbaminohemoglobin, HbCO2. I don't want to write carbamino again, but more formation of that. That's number one. Number two, this O2 unloading allows you shift this equation to the right. So I have to name this equation. Let's call it the carbonic acid bicarbonate equation. Probably just call it our carbonic acid EQ to the right. You shift it to the right, meaning you're going to get more of these products on this side. That makes sense. You're forming more bicarbonate because that's actually the number one way you transport it. All right? So both of those things, you're just getting more CO2 into the blood. That's basically what you're doing. And of course, the name for that is Haldane. So consider number one. Number two, call that Haldane effect. Which is basically following as a result of Bohr. First, Bohr effect happens, more unloading, so you get more CO2 loading, and that's Haldane. Now, if you want to look at a graph of that, this is a graph of, say, Haldane. Factors that influence O2 unloading, that's Bohr, but then Haldane CO2 loading. What this graph is saying, if hemoglobin is 100% saturated, dark blue line, that's how much you could get of the CO2 in the blood. So this is PCO2 tension rising, how much CO2 is in the blood. So, but if hemoglobin is 100% saturated, you get less into the blood. But if hemoglobin is 0% saturated, the whole curve shifts up. So that any given PCO2, you're pushing more into the blood because of the whole, analogy I gave, more get off the bus, more can get on the bus, right? That's all that graph really shows. So to kind of check for understanding here, let's go through a list of questions just to make sure you're with all that. Actually, I just wrote it. I don't want to do it again. This right here, see those four things? Is it more or less acidic? You tell me. It's, you drop the pH, it's more acidic. Yeah, it's kind of like the reverse thinking. I always have to do mental gymnastics when I think about pH. Do you remember what pH is? It's a logarithmic schedule thing of hydrogen ions. The whole thing, What is pH 7? Isn't that the neutral one? It's not water. But what is that 7? What is? I think it's 10 to the negative 7. Right? That's a number. And the 7 is that. So what if you go, pH, oh, I'm sorry, I put 7 twice. 7, 6, 5, 4. pH is but what does this number refer to? It's like the power of hydrogen, right? So think about that. This is actually 10 to the negative 4. It's actually more hydrogen, right? So that's why when pH drops, more hydrogen, it's more acidic. So anyway, long way of saying, reminding you of what pH is. We're going to talk about pH more. Anyways, number one, blood is, let's say it's, more acidic. What about PCO2? Higher. BPG? Higher. Body temp? Higher. Okay, so that's kind of what I was hammering into you. All those changes that are right here. Okay, so because of this, these things, we talked about the whole shifting thing. Which shift is it, to the right or to the left? It was this one. The dotted line, shift to the right. Solid line is normal. Normal, what's P50 under normal conditions? 27. Good, you guys got that. But it changes, it increases with this rightward shift, which occurs as a result of these things changing. Okay, so that's what we said for that. Then I went into this thing here where I said, these things facilitate oxygen, which one was it? Loading or unloading? Unloading. This is the Bohr effect. So of these multiple choices, I was trying to get you to consider these things facilitate oxygen unloading. It's the Bohr effect. Choice D would be correct. Then I'm saying, lastly, as a result of oxygen unloading, we get more CO2 loading. And this is the Haldane effect. So that's kind of the train of thought I was taking you through. So if you need to do that yourself a few times before it solidifies, go ahead and slide you there. I always put this to make sure I talk about everything. And I'm glad I have this slide because I forgot to teach you this. So let me do this with you right now. Maybe ask to do it on your exam. Everything else I talked about. Yeah. Calculating O2 content. Let's do that. No, we're not doing this. I'll remove it from the test. The clock is killing me here. I gotta move on. I just made an executive decision. Before we transition into the lab, I would like to talk about the remaining quizzes and exams that are upcoming. We're pretty much up against it here, folks. Now, if you look at the schedule, I did this when you guys were on break.
There's no written part, right, of the exam?
That is correct.
Okay.
plenty of time for spirometry. I'm going to demo the lab. You should have at least a couple hours to run that thing. And I already talked about how these two things will be on Proctorio. I'll make this available, Lecture Exam 6. So I just finished, and now you're ready for it. And it'll be, I told you the due date, do you remember? Thursday. Yeah, I'll make it available today. I'll work on it after class. So all of these things, quiz, histo, test, and final. Okay, so I made a list here. Hold on a second. I've decided to make a list and put some things on Proctorio. So, these are on Proctorio. The big thing I'll skip to is I'm going to put Lab Practical 3 on Proctorio. Okay, so what I'll do is I'll provide a bunch of pictures and you can just study. I'm finding out I'm not having all the lab time I would like to give you to study the models in class. So I'll give you a bunch of pictures, and some will be pictures of models. Well, you can just study those at home. I don't have to worry about giving you an appropriate amount of lab time because we really don't have it. I got a lot of information to cover. Okay, so that test just became much easier, but here's the catch. It was scheduled for in-class 8-1. I'm bumping it back. You got to do it a day earlier. Okay, so it'll be a multiple choice format, 50 things, just like the other ones have. Any questions on that? Now this one, I'm bumping it back a day because on Proctorio, I have to look at my grade book and basically, if it red flags you, I mean literally it red flags you. It color codes you red, yellow, green in terms of suspicion level of cheating. It'll even put a criminal icon next to your picture. I mean, they really go all out. So if something happens where I'm like, oh, what the heck is that? And I have to confront you, I hate doing that, but I need this day to do it because you have to come to this day. Okay, so that's kind of why I need to bump it back a day for the Proctorio thing, because if I have it on that day, I may not see you. I just may have to fail you. You don't have a chance to appeal yourself. Okay? My roommates were just playing a joke on me. Well, I need a chance to talk to you in person. Okay, and so that's why it's bumped back a day, but the format is much easier for you. So I'll try to provide those pictures for you today or tomorrow. So let's bump it back. Here we are. These two are going to be due on Thursday. I'm going to make them both available today. The quiz is already available. I worked on that this morning before class began. You can do that now if you want. Well, not now. Wait till lab's over. Lecture Exam 6, okay, that's coming. You know what that's all about. There's no written part, just the 50 multiple choice. So this is worth 50. The test is worth 100. Now this quiz and digestion is your regular quiz on Friday, and that'll be in class. The digestive quiz, I have that set up to be on Proctorio too, so I'll try to teach those slides prior to the 29th and give you some time to work on that. So these are all due dates. Okay. I said the Lab Practical 3 will be due on that. I believe that's a Wednesday. I'll try to make it available a day earlier, but it'll be due that day. And then these are the last 2 days of class, Thursday and Friday, both in class. So I want to say this, I usually don't say this to the whole class, but if you're a student enrolled in DSP&S, since we're doing nothing else on either of these days, you need to schedule your appointment for 8 o'clock, 8 a.m., 8 a.m. And usually I'll have an individual conversation with DSP&S students, but it's about a third of the class. So I'll just say to everyone, if you're a student enrolled in DSP&S, 8 a.m. And if it's not confusing because you have to be here at 8 a.m. if you're not a student in DSP&S. 8 a.m. I'm going to give you like the usual, 90 minutes? Go home early, right? Final. The final is optional. On this day, I'll be really quick to get your Scantron entered that day.
Thank you.
So you can kind of look, see where you stand, and make a decision. If you need the final is great for students who are on the bubble. You just missed an A, you just missed a B by that much. And I always get the email Oh, well, is there anything I can do? Yeah, you can take the final. You can ace it. Yeah. Now, after the final, you can't send that email. Is there anything I can do? No. That's it. The class is over. I do get those, even after the finals. It amazes me. It's like, is there anything I could do? Well, you should have aced something. So we can have that conversation now. What can you do? You can do the best you can of all of these things. Okay, so I'm going to demo the lab. Are there any questions about all of this?
Is the lecture?
Okay, one at a time. Over there first.
For the lab practical, can I use the notes or no notes?
Yeah, anything that's listed as procto, go ahead and use your notes.
I was thinking
Yes,
notes.
Diana?
For the lecture exam, did you say that there wasn't going to be a written, or is there a written portion for number 7?
6, no written. 7, no written. All multiple choice. Any other questions?
That was my question.
Okay, okay, very good.
Are they 50, the lecture, exam 7, and the final 50 multiple choice?
Well, the exam, final exam, has no point value because it's just a replacement.
Okay.
So it depends on what exam you choose to replace.
I was just wondering how many questions it would
50.
be. Yeah, okay.
Okay. Lecture exam 7, because there's no written, I do make that a little more, maybe 60, something like that. I'm going to say 60 to 75 for lecture exam 7, because that covers a lot, digestion and urinary. So maybe 60 to 75-ish. So that's 2 points a question. So it's going to, the point value will range from 120 to 150. I haven't written that exam yet. Yeah?
So if we're DSPS students and we do exam 7 and it's over there and they're going to take it to your box, are you coming back to the school to
No,
get it?
I'm going to set it up to pick it up. So if
You'll
like,
do that for us?
I'm going to go there like at 10, at 11. Are they done yet? Are they done yet? Because I'm waiting to get out of
You're
here.
the best, thank you.
Yeah.
Well,
Okay.
Yeah, go ahead.
they open at 8:30, and second.
Okay, I'll consider that.
And second, for lecture exam, final exam. So when you say it's multiple choice, so let's say if you're replacing an exam, it's only replacing the multiple choice part, or also
Oh,
the
yeah.
written.
I'll replace both parts.
Okay.
Okay, and I listed them separately, but I'll only replace it if it's a higher score.
So what we have to do is add both together to see which one we will have less percent.
Yeah, you do the math, and I can go
Yeah,
over it with
I
you if
did
you need
that
help with
already.
that.
Okay.
Okay, is that it? Any more? Question in the back?
So your grade that you're replacing,
What's that?
um,
Yeah, you're replacing, yeah, gotcha.
if it's not higher, you're just going to disregard it.
Yeah, if the final is not higher, like say you got a 60, the stinker test way back, and your final's a 59, I'll leave the 60 alone. So you have nothing to lose. Now usually when I say that, you do terrible. You want to ace that final, right?
Yeah.
I rarely see that. I rarely see it. I hate to say it. I'm just speaking about what happened. I've seen it happen once or twice where a student nailed the final. I usually don't see it. You have a study guide, so do the best you can.
In the study guide you put on the very back, like be very specific to circle which one. You seem very picky about that. Is that going to be on the final? Pick
Yeah.
This and if you don't, I just wanted to.
Yeah, I want you to pick it. I'm not going to make the decision for you.
Okay.
It's all be sure that if you show up for the final, I know what you picked, right? Okay. So I'm going to demo the lab, but I do need time to get things out. So go ahead and take about a 5-10 minute break, and I'll demo the lab. You guys can get into it.
Yeah, I know. What did you say? Are we going to break you see it in break? Everybody's walking around this time. Yeah, talk about how because I'm busy talking about the class.
let's do that right now before I forget, okay?
Yes.
For the page number.
I went through, I counted, all night. Double check.
Sorry, I know it's late.
No, I just know. Who?
So if I started at stuff and it doesn't check, can you beat you after?
Yeah. On my end, that's what I see. Right? Okay, so let me know if you don't get 50. I'll give you another attempt.
Okay, all right. Well, fingers crossed that it works out good, because
Yeah.
the exam worked out fine after.
Okay.
So,
Okay, that's
yeah.
good to know.
Yeah, but did you have to change the exam? You went back in there and changed it? Because I ran the exam over the weekend and said no, and then by when I did on Sunday, it had the contract. Why it showed something before and after.
What I just showed you, I entered all those before the test. I think on yours I did forget, and then I changed it.
Oh,
But this one you saw, it's
yeah,
already changed.
it's right there.
So you should have your undivided.
Okay, awesome. Okay, thank you.
Good. Okay, you can leave that on my desk. I can check what you guys do in the lab. Much ease. Okay, I can check it.
Week 7.
Yeah.
Oh, you're 7.
Yeah. Oh, actually, this is the first time I've ever.
That's correct.
Cause I was listening to it, and I was like, help me. Yeah, the normal. She is. I think I just like went in through your camera. If it's still recording, Professor.
Oh, shoot.
Yeah.
Cut that short before I upload it.